All right, so like I said in the last unit, last section of our course, we look at transformation of functions, just any general function. Well, now we're going to get specifically in to the transformations of polynomial functions. All right, and so what I'm going to do here is just kind of a little recap of what we went through before. So I'm going to do B and D here. All right, and it says, describe the transformations that are applied to y equals x cubed to create each of the following functions. All right, so that's again where you have to be able to identify your a value, your k value, your d, and your c value. So right away, I got my d value here, or sorry, not my d value, my a value. Now it is negative. And as I mentioned in the last class about having an a value as negative, it reflects, or the graph, or the, I guess it is reflected, easy for me to say, across the x-axis. Well, flips it over the x-axis. A is the magnitude of 8, or the absolute value of A is 5. And so that means we have a vertical stretch by a factor 5. Now, the k value there's usually going to be some double brackets, and there isn't. So the k value, well, I won't say there is no k value. It's just 1, which means nothing special's happened. But then I look at the d value. See that negative sign when it's x minus 1 cubed? That minus sign is supposed to be there, so this is shifted right 1. And then our c value is 2, so it is also going up 2. All right, so again, that's just a little recap of what we did before. Now I move over to D, a whole lot more going on. Again, I look at my A value, and so it's, again, reflected across the x-axis. It is also 4, the absolute value of A is 4, so again, it is a vertical stretch by a factor of 4. Now we look at the k value. I'm going to move my word there here a little bit so you can see the equation better. So now the k value is in there. It's -3. We got those double brackets going on. And so that means we have a horizontal, or it's reflected because of the negative sign, across a y-axis. So it's flipped across the y-axis, this graph, if we had to graph it. Now we have a 3 there. Now, k is, again, a little bit different, where because the k value is greater than 1, the absolute value of it is greater than 1, we now have a compression. And so we have a horizontal compression by a factor of 1/3, 1 over the magnitude of k. There we go. So that one's always a little bit different. You got to watch out for that. Again, I mentioned that the last part, or last unit. Then again, looking for the D and the C. So inside the brackets there is our D, and again, always looks the opposite. That's the trick part. So it's shifted. This time we have a -2, so it's shifted left 2. Again, even though it looks positive, it's not, because there's a negative sign in the equation. There's a negative sign on the -2. They come together to give us a +2. And then the C value is normal, so it's up 1. All right, so again, that's just spotting transformations. In this case, for C, when the A value is a fraction, do we write, hold on, I'm going back to the chat. Do we write that a vertical stretch is happening when A is a fraction? Ooh, when it's a fraction, well, a fraction's not so much that it's a fraction, it's how big is it compared to 1. And so 2/3 is still less than 1, so it would be a vertical compression by a factor of 2/3. Okay? Now, great question, by the way. What happens if A is 5/3? Well, then A is greater than 1, and so then you would have still a vertical stretch by a factor of 5/3. All right? So it's not the fact that it's a fraction, it's how big is it relative to 1. All right, so that's something you got to watch out for. That's a trick I always throw on a CAT. throw an a value of 5/3, and it's a good little trick there. All right, so good question there. All right, next up, example 2. For each graph, determine the equation of the function in the form y equals a x minus h squared plus k. Yeah, see, this is old school grade 10. This is that should be an x minus d plus c. That's what I hate about the textbooks. In grade 10, they call them H and K, and then in grade 12U, they call them D and C. Even messes me up because I teach grade 10, I teach grade 12. All right, but then describe the transformations that were applied to y equals x squared to obtain each graph. All right, so I'm going to miss A here. We're going to, because it's a little bit more straightforward, I'm going to go right to B and C here. Now, I want to be able to determine the equation of these quadratics, right? Now, the first thing is, when we're determining the equation, I want the A, the K, the D, and the C. Not giving myself much room here for the next one. All right, now, here's a key point, and that's the vertex. The vertex is special because it's the one spot that on a quadratic that doesn't get affected by stretching and compression, either horizontally and vertically. And so if this particular quadratic here has a new vertex at 1, 4, that means that our D value, this graph has been shifted right 1 and up 4. All right, so there we go. So we got 2 values right out of the gate, which is great. Now we got to find our A and our K. Now, the first thing is we've got 2 points here. All right, now I'm going to use, you've got your pick here of which points. I'm going to use the one with the positive values, 629. Make sure I did that in my note too. Yeah, it looks like it. All right, 629. Now, what I'm coming back to is our transformation formulas, where we have x2 is equal to x1 all over k plus d. And then we have our other formula there where it is y2 is equal to a times y1 plus c. Now, this value here, this is where things get a little different, is that this is our transformation point. So that's our x2 and that's our y2. The 29 is our y2 and 6 is our x2. Now, on a quadratic, when you go 1 over, right, we have the original function here of y equals x squared. If I put a 1 in for x, well, 1 squared is 1. 1, 1 is now our x1 and our y1 that we're comparing it to. So that 1 point to the right on this quadratic in our original would be 1, 1. The transform point is 629. And so what we're going to use is our old well, I won't say they're that old, but our transformation equations here to find our K and to find our A. Then we can write the equation. All right, so is there any questions about that? That's a little bit of a conceptual thing there. All right, so we have both the original point and the transform point. What you're trying to do is find the A and the K. All right, so it looks like I'm going to find the K first here. So the x2 is 6. The original point here was at 1, the original xy coordinate. I'm trying to find K here. All right, and my D is plus 1. There we go. So now I got to solve this equation. Well, I'm going to move this 1, this plus 1, over to the other side. So it changes sides, change signs. I'd get 6 minus 1. It's going to be 5 equals 1 over K. Now, for those of you who are in my math class before, and again, I don't know what your math teachers taught you before, but the best way to deal with 5 equals 1 over K is I like to create a fraction equaling a fraction. All right, so that's the reason I do that is because then I can cross multiply and all the fractions are gone. It's an easy way to solve the equation. So I got 5 times K, which is 5K. And then that's going to equal cross multiplying 1 times 1. And so I'm going to divide both sides by 5. And, well, then k is just going to be 1/5. Bingo. I got 1/5 as k. All right. Now I'm going to do the same process here. Only I'm going to use my y2s and my y1s to find a. A little bit easier equation here because we don't have a fraction involved. All right. So now y2 is 29. Equals a times y1, which was 1. Okay, that's easy enough, isn't it? Then plus 4, because that's my c. All right, well, I'm going to move the 4 over to the other side to solve for a. And because, again, it changes sides, it changes sign. 29 minus 4 is going to be 25. Equals, well, 1 times a, which is just a. Hey, there's my a value. It's 25. All right, so now here's what I'm going to do. I'm going to write this equation out. It is a quadratic here, so I'm going to write it out over here, which this is b. So I got y equals, all right, my a value is 25. Then we go with the square brackets for k, and it's 1 divided by 5. Then we got to go round brackets. Whoops, round brackets. D is 1, so I'm going to have an x minus 1 in those round brackets. Again, square bracketed up, and that is, whoops, I got to do that inside. Let's see here, make that, oh, no, outside. And to the power squared, and then I got my c value after, plus 4. All right, so there's what that equation would look like. Now, here's the key here. It wants us to write it in this form. See how there's no k there? Right? Y equals a times x minus d squared plus k. Because you can move the k out of these square brackets. But the problem is it's squared. So just like I was talking earlier about, if it's squared, there's actually 2 of them in there. So when I bring it out, I got y equals 25. There's my a times 1 over 5. Because it's squared, times 1 over 5. And then I got the rest there. I've got the x minus 1 squared. And, of course, the plus 4. All right. Now, if I take 25 and I times it by 1/5, and then I times it by 1/5 again, guess what I get? Just a 1. And then I got, then the rest is x minus 1 squared plus 4. There we go. And there's our quadratic equation simplified in that form. We just had to find our a and our k, or d and our c, and then substitute them in. All right, I'm going to do one more of those because I know it's a little tricky, right? There's no question about that. All right, so we get to the next one here. Again, there's the vertex, important spot, because again, I got my a, my k, my d, and my c. Well, this particular vertex, because again, the key with the vertex in a quadratic is that it doesn't get affected by vertical stretching and compression and reflection, because it is that's the middle point. So our d is 3. Because this vertex has been shifted right 3 and down 5. So there's my c value. All right, I got both of them. 3 and negative 5. But now I'm going to, again, use my equations here. The x2 equals x1. Again, I need to pick a point. Well, of course, I'm going to go with 711 here. All right, so, and again, the original point, your x1 and x2, or x1 and y1 are 1 and 1, because that's the first point right in a quadratic. All right, so I'm going to use my equations again. So here we go. The x2 is 7. So I'm going to have a 7 equals. My x1 is 1, all over k. And my d value is plus 3. All right, I'm going to move that 3 over to the other side. So again, changes sides, changes sign. So it'd be 7 minus 3, which give me a 4. Equals 1 over k. All right, and again, because I want to solve this equation rather easily, I'm going to go a fraction equaling a fraction. And so I have 4k. 4 times k equals 4k, and 1 times 1, well, that's 1. I'm going to divide both sides by 4. And so I get 1/4. There we go. There's k. Bingo. All right. Next up, I got to find my a value, right? So again, I'm going to use my formula y2 equals a times y1 plus c. There we go. There is 11 is my y2, and again, y1 is 1. Let's give you a good look at that. There we go. All right, so here we go. y2, that's 11 times a times y1, which again is just 1. All right, and then my c value is minus 5. All right, now to solve this equation, I'm going to bring this minus 5 over to the other side. Again, changes side, changes sign, so it's going to be a plus 5. So 11 plus 5 is 16. And a times 1 is just an a. So there we go. I got my k is 1/4. And my a is 16. And so now I substitute into my equation. What's it going to look like here? I'm going to have y equals, my a is 16. There's my square brackets because I have a k that isn't 1 here. It's 1/4, which is always in front of the round brackets. I have an x. Again, what was my d? D was 3. So I'm going to have a x minus 3. Square brackets because it's all inside the function. Squared, and then our c value was -5. Minus 5. But again, if I'm simplifying it, now this is how I'll ask you to write it, where we have a, k, d, and c. But I know the textbook is will not do that, possibly, from what I remember. All right, so again, I can drag that k out, but because it's a quadratic, there's 2 of them, so I got 16 times 1/4, there's 1 of them, times 1/4, there's another one of them. And then the rest is normal here, where we got the x minus 3 squared minus 5. And let's see, I take 16 times a quarter. Guess what? It's just 1. And then times x minus 3 squared minus 5. And there we go. All right, just checking the chat there. All right, now, let's see here. Moving on to something a little bit different. Because we're going to get back to these equations again today, but we're going to move to example 3 here, which is, and I'm only going to do one of these, determine the x-intercepts of each of the following polynomial functions, round to 2 decimal places. Because one of the things we have to find is x-intercepts. Now, this was not written in factored form. And that's why we're doing this, because in factored form, it's easy. You can just look at each of the brackets and figure out what number makes the brackets equal to 0. And not so much here. All right, so the key is that when you're finding the x-intercept, y is equal to 0. That's a huge idea there, all right? So just like when you have a y-intercept, x is equal to 0, which often is much easier to figure out. So in A, if we want to find the x-intercept, well, I'm going to make y is equal to 0. So then I got, whoops, backtrack there. 0 is equal to 3, x minus 2 to the power of 4 minus 5. All right, now I want to solve for x. So some of you who weren't in my class last year, I'm not sure if you've done this before, but we did do it in 11U. But again, here's what happens. I'm going to move this minus 5 over first. And as I've said a few times today, changes sides, changes sign. So it's a positive 5. Then I got 3 times x minus 2 to the power of 4. All right, now I can't get out of these brackets because this 4 here, this exponent's got basically those things trapped inside. But what I can do is get rid of this 3. Now it's attached, so the only way to get rid of it is to divide by 3. All right, so then I've got 5 divided by 3, which, let me see here, 5 divided by 3 is 1.67. I wanted to do that in a different color. There we go. So 5 divided by 3 is 1.67. Now it's equal to x minus 2 to the power of 4. Now, as I mentioned, that x minus 2 is trapped inside that bracket because of this exponent. So the only way to get rid of this power of 4 is to take the root. But a lot of people are used to taking the square root. Well, you can take many roots. We are going to take the 4th root. Now, this is something a lot of people struggle with in their calculator or need to learn in your calculator. Usually there's a button. There's a few buttons there. Well, there's a button, but it looks different. Can look like this. That's common. On your calculator, it can look like y to the power of 1 over x. All right, where you would y would be the 1.67, the x would be the 4, or in this case, you would put 1.67 in, and the x would be the 4. All right, so you got to figure that button out in your calculator. Now, here's the thing. When we have an even degree polynomial, you actually get 2 answers. The 4th root of 1.67 is plus or minus, let me see here, and I take it in my calculator, and I get plus or minus 1.14 equals, now again, that gets rid of that little 4, x minus 2. All right, now, again, the whole idea here is get x by itself, so I'm going to move that minus 2 over to the other side. Now, there's a plus or minus in front of this 1.14. So again, that negative 2 changes size, changes sign, so it's a positive 2. All right, so now I can find my 2x values. All right, so I got positive 1.14 plus 2. Well, I know that's going to be 3.14. And x is equal to, so we're getting 2 x-intercepts here, negative 1.14 plus 2, which is 14 cents off, is 86.86. And there we go. So there is our 2 x-intercepts. All right. You know what? I'm going to do another one. I'm going to do the other one here. I'm going to do B. All right, so B is, I'm going to write that down again. So let's go with B. We got y equals x plus 3 cubed minus 5. All right, now again, I'm finding the x-intercept, so y is 0, so I might as well just erase this y here and plug in a 0. So once again, for B here, I've got my 0 in for y. I'm going to move that minus 5 over to the other side, so it's a positive 5. And I've got that x plus 3 in brackets. Cubed. All right. Now, again, that x plus 3 is trapped in brackets. But I can get rid of this little 3. Now, last time there was a little 4 there, so I took the 4th root. This time I'm taking the 3rd root. And what I do to one side here, I got to take to the other. And so now here's where something's a little bit different. This is why I'm doing this one for sure. Is that when you have an odd degree, so 3 is definitely an odd number, you only get one answer when you take the root of your number. All right, so the 3rd root of 5 is just one number, and it's 1.71. So again, that's something you got to figure out on your calculator, how to type that in. Then we have an x plus 3 here. Because again, that 3rd root took off that little 3. I'm going to move the positive 3 to the other side. So I'm going to have 1.71 here. 3 changes size, changes sign, minus 3. And now I'm only going to get one answer for my x-intercept. I'm going to get x is equal to whatever 1.71 is, minus 3, subtract 1.29. And there we go. So that's something when you're taking the roots of an even degree, you get 2 answers. If it's an odd degree, you get 1 answer. All right. Just checking the chat here. All right. Woo. Long day, eh? All right. So here we go. So we're looking at the cubic function again here. All right. So the function f of x is equal to x cubed has been reflected in the x-axis, horizontally compressed by a factor of 1/3, sorry. Horizontally translated 5 units left and vertically translated 4 units up. 3 points on the resulting curve are -6, 31, -14, 3, and 3, -11, 3, and -60. All right. Determine the original coordinates of these points on our function. So again, the original coordinates, we're looking for x1. We're using those equations again, and y1. These are 3 different sets of x2 and y2s. Now, we've got a bunch of words up here. And so this is going to help me figure out my a value and k and d and c. Now, the first part says it has been reflected in the x-axis. Now, it doesn't say anything about vertically stretch or compress. So that's telling me that it's reflected in the x-axis. A is negative. And because there is no horizontal or vertical stretch or vertical compression, the magnitude, sorry, the absolute value of it is just 1. Now the k value. Let's get to that, the information. It's horizontally compressed by a factor of 1/3. Again, this is the trick here. When it says that, the k value is actually in the bottom of your fraction. All right, so k is actually equal to 3. Just as if, no, I won't say that because that'll mess people up. All right, we'll leave that alone. K is 3. All right, now it's horizontally translated 5 units left. That's telling me my d is -5. And vertically up. So that c value is equal to up 4. So from those words, I got my a, my k, my d, and my c. Here is I'm going to do my first point. This is going to be the only one I'm going to do here because you can check the other ones out in our note. There's my x2, and there's my y2. All right, so if I want to determine the original coordinates, again, that's what we're looking for here, the x1 and the y1. Going back to my equations, so again, x2, I'm going to write them down, is equal to x1 all over k plus d. The other transformation formula, again, y2 is equal to a times y1 plus a c. All right, so let's see here. What was the x2 again? -6. So let's pop that in there. All right, we want x1. K was 3. And my d was -5. All right, so let's see here. I'm going to move that -5 over to the other side. Again, changes sides, changes sign. It's going to be a +5. So -6 plus 5, -1. Equals x1 over 3. And again, this situation, I just like to, when you got something equaling a fraction, I just like to create a fraction equaling a fraction so I can cross multiply. All right, and so in this case, well, 1 times x1 is x1. That's great because that's what we're looking for. And then the other part of the cross multiplying is 3 times -1, which is just -3. Perfect. There's 1 down. Now we get our y1. So we know our original coordinates here. So y2, again, was this one, because, again, there's 3 different sets. We're only going to do one of them. Y2 is 31. A, what was A again? -1. Okay, let me go up again. Just have a look at those. A is -1. We're going to need that, and C is 4. All right, so -1. Our y1 was, we don't know. That's what we're trying to find out. And C, there's my memory. There it is. I forgot already. +4. Okay. So then I move, I want to solve for y1 here. I'm going to move the 4 over to the other side. So again, changes sides, changes sign. 31 minus 4, 27. All right, equals -1 times y1. So we're not quite done yet. All we have to do here is divide both sides by -1. All that's going to do is change your y1 now to a negative 27. And there we go. We've got our original coordinate, which is negative 3, negative 27. So today, those transformation formulas, before we always had x1 and k and d and a and c and y1, and we were always finding x2 and y2. And today we worked the opposite way. We end up finding the h and the k, or the a and the k's, and we end up finding x1s and y1s. So we work on both ways. Can I explain how I got k? Where was that? Whereabouts? Just gonna